Hi everyone, I'm Julia from Krannich Solar. Thanks for joining our webinar today with Goodwe. Before we get started, I'm just going to give a quick presentation about Krannich. Krannich Solar is headquartered in Germany and was founded by Kurt Krannich. Since being founded, Krannich has expanded into 26 different countries and can ship to over 100 countries. As a privately owned and self-financed company, we hold a significant market share and rank among the leading solar wholesalers globally. With 29 years of experience in delivering solar products worldwide, we've become experts in the field. Our international purchasing power helped us build strong relationships with your favorite manufacturers, such as Goodwe, to secure the best pricing and availability. In 2005, Krannich expanded into the US, opening our first branch in New Jersey. Today we have branches in California and Florida, and we've expanded into Texas, with additional warehouses across the nation. Our US team consists of over 80 employees that service the Americas and strive to offer the best services and options to our partners. We're growing every day, so keep an eye out for where we might be next. Krannich is the top partner for installation companies seeking PV system products. In our role as an internationally operating wholesaler, we can make a significant contribution to shaping the energy transition. With every PV system we supply, we come closer to the target of carbon neutrality and fulfill our mission of paving the way for 100% renewable energies. Our company values are the drivers of our success and inspiration in a dynamic market. Throughout the years, we've grown our product portfolio to provide over 5,000 products. We've partnered with leading manufacturers worldwide to offer the best material for a project of any size, whether it's an off-grid system, 4-panel shingled roof, or a megawatt flat roof. Choosing Krannich means you'll never work alone. Our streamlined ordering process ensures that each customer receives a dedicated sales rep, guiding them through every step from project design to on-site delivery. The solar industry is always innovating and changing. At Krannich, we're committed to keeping you informed about the latest products and technologies. We collaborate with industry leaders and seasoned professionals to offer first-hand training on everything you need to know, and it'll always be for free. And this concludes my portion of the webinar. Here's our contact information if you would like to reach out for a quote or if you have any questions regarding the products or services we offer. And if you have any questions throughout the presentation, please use the question box to ask them. Thank you again for joining us. And now I'll pass along to our team from Goodwe.
Thank you. Thank you so much, Julia. I'll wait to get the screen command. Thank you. Okay, so I got everything on presenter mode now. Thank you, everybody. Thank you for taking the time. Thank you to Krannich, our partner. And I'm hoping today that I'll have the opportunity to show you the Goodwe product. First, a little bit about us. And we are a world leading in PV inverters and storage. We offer residential and commercial applications. We have a installed volume of greater than 52 gigawatts. Our office is in Colorado in the US. The team in the US is based out of Colorado. In addition to our products, we also have a GE license partnership. So you might see our inverters with the GE brand. We are about 5,000 strong within the company. And now, as of 2022, we haven't gotten the latest 2023 numbers yet. We were about $735 million company. As I shared earlier, we have our headquarters in Colorado. So here in Colorado, we have our product management team, our executive team, our tech support team is here as well. If you ever had any questions or concerns, you are calling us here in Colorado. If something was to go wrong with your product, with the product, any RMA, any replacement will happen from here, from Colorado. Now, for brand new product, it ships out of California. So a big overview of the UL version. products. If you go to our Goodwe website, the global website, you're gonna find a huge portfolio of products. But we do have a US specific website so that you don't get lost into all of the products that are not applicable for the US. So for the US market, and obviously you can always rely on Krannich to point you to the right product selection for your project. But within the US product line, we have, starting on the screen on the left side, our string inverters, which is the MSUS. Next, we have the storage inverters, AES, our batteries, our automatic transfer devices, and we also have CNI inverters, which I hope to have time to touch on them today. So ask your questions. If I have time, I'll answer them during the presentation, but I do want to get to talk to you about the CNI product. So perhaps if I don't have time for the questions, I will come back to you personally via email and answer all your questions. So please put the questions on the poll in the question box, and I'll make sure that if I don't get them answered today, I will come back via email. A little bit about the MSUS quickly. Because it isn't the focus for today. Today we want to focus on the storage. String inverter starts from 5K to an 11.4K. It's all of the inverters are the same size. So just because you have a 5K inverter doesn't mean it is going to be smaller in size than a 11.4. And that is actually done purposely so that it makes it easier for the selection of the installation site, so that way you know where the inverter is going to fit. Obviously, it's outdoor rated, so it can go outside, usually installed by the meter. Depending on the size of the inverter is how many MPPTs it has. The two smaller ones have 2 MPPTs, the larger ones have 3 MPPTs. So as I shared, my big focus is on the storage inverters, and within the storage inverters, I have 2 models. They're exactly the same in the look, so I'm only showing one photo here, but you see the dimensions are all the same from the 5K to the 9.6, and we have the hybrid version, which is the AES. AES is a DC coupled storage inverter. And we also have the AC coupling version, which is the SBP inverter. So here is some of the specifications for both of these inverters. Obviously, AES has an MPPT range because it's DC couple. So you can string 2 strings or 4, depending on the size. The larger versions have more MPPTs. Built-in rapid shutdown transmitter, built-in arc fault, and it also comes with a built-in power meter, which I will share with you a little bit more on that, specifically about what we do with the power meter. One of the things that I always forget to mention, I kind of take it for understood, but it's not true. Not everybody can do the same. So this is a storage inverter. But if you had a scenario where the customer is ready for the solar, the PV is ready for the inverter, is definitely interested in storage, but they're not ready to buy the batteries today. This inverter is what we call battery ready, meaning that you can install this inverter with the array and bring the batteries later, a year later, 6 months later, whenever the customer's budget allows it, you can bring the batteries. Another thing that is also unique for us is that, yes, we do have our own batteries, our links, which I'll talk more on the specific technical terms later on another slide, but we also have partnerships with other battery manufacturers. So we work with BYD as well as LG, and with everybody we have our certification UL 9540, and we also have UL 9540A. So you can use this inverter as a string inverter, PV only, bring the batteries later, or the other way. You may have a customer that says, I just want storage. I don't want to run the generator. I want to use the storage. I don't want to have solar, or I don't have space for solar. This inverter can operate as backup only without any solar. No problem. So with AES, you have a couple of options. You can do the partial home backup, which is the most common form. Now, if you ask the customer, when you're talking about storage, obviously every single customer is going to tell you, no, no, I want the whole home. And yes, we can do whole home backup too. It's the next slide, but let me touch a little bit about partial home backup, because in my experience, 99% of the time, that homeowner that said, no, I want the whole home backup, and you sit down and you start explaining, yes, that is possible. The technology is available. It just means more batteries for overnight, right? So if you have a power outage, you want to have the whole home backed up with the batteries, right? Because overnight, you're not going to get the help from the solar. And then once you start doing the math and you start talking to the customer and educate the customer, the owner of the system, most of the times, in my experience, you are able to bring him back down and say, okay, what are my essential needs for a power outage, right? And most of the time, you'll find that the customer will have the same answer. Well, the refrigerator, of course, because I want to save my food, some outlets to plug in, charge phones, some lights, in minor things such as that. And that is very realistic and very common. This is the most common system that that we can put together. So for this system, you see there's a couple of components I'm showing here in the picture. Obviously, you have the inverter, you have the array, you have this transformer. So one of the things that happen with these types of inverters is because in our electrical homes, we have most of our loads are 120. There very rarely you have 240 loads, maybe a dryer, maybe big appliance that do 240. Then you have loads split between L1 and L2, and it's almost impossible to balance L1 and L2 because you don't know when the customer is going to go to the kitchen and turn things there, and then somebody is in the bathroom turning other things, right? And you don't know where L1 and L2. So don't forget, when you're specifying this product for your installation, don't forget the transformer. And obviously, Krannich will assist you to let you know that you need this transformer. It will simplify things. So as I said before, we do offer the whole home backup. So customer says, no, I really need everything backed up because I need the hot tub in the middle of the night when there's a power outage. Yes, we can do that. And it just means more batteries. And so we have to be a little more careful because we need to calculate what's going to be on in the middle of the night because the solar is not helping us. But then you see my drawing changed a little bit here. There's something else was added. And in this case, it's an automatic transfer switch. So this is our Goodwe automatic transfer switch because it's actually talking to the inverter. So you buy the Goodwe transfer switch with the inverter, automatic transformer, and the batteries. And what happens now is when there's a power outage, you know, I'm gonna go back and say one thing I missed. I want to say it. What happens in this scenario when we have a partial home backup? What happens when there's a power outage? Because you see the Goodwe inverter is directly connected to the grid. The inverter inside the wiring compartment, it has sensing the voltage of the grid and is monitoring the voltage of the grid at all times. If the grid is out of specs, right, you don't even need to have a power outage because right before a power outage, the grid goes out of specs, right? The voltage starts dropping in the frequency. So the inverter actually will disconnect. This inverter has an internal disconnect contactor. So it will isolate the home, the backup loads from the grid. and it complies with all the anti-islanding IEEE 1547. But one of the features that this inverter has is that this transfer is very fast, actually almost not noticeable by the customer. It's in the range of 10 milliseconds where this inverter will transfer, and the backup loads are going to have power from the solar and the battery. Now, back to the whole home backup, you see now I have a transfer switch. And what's happening with the transfer switch now is transferring the source, right? First, the loads are being supplied by the grid is out, the transfer switch switches to backup mode, and now the source becomes the Goodwe inverter with the batteries. Again, supporting the PV with the PV and the battery. And the one key, and I think a lot of us are doing this. I was listening to one of my competitors in the market, and we're all very friendly. So I really love what they said. They had a similar presentation, and they were talking about whole home backups. And one of the notes from the presenter was, but not with one battery. And I think that's one of the pain points that we have seen in the industry, is that we are missing the step. If we're going to do whole home backup, we need to make sure we can support the customer, because the customer is not going to be satisfied if the batteries run out in a couple of hours, right? So if we don't do a good load calculation, that possibility is real, and the customer is looking for a robust system, and that can only happen if I have enough batteries so I can be ready for the morning when the sun comes back up again. All right, let's talk a little bit about the internal logic of the inverter, how the inverter can be configured to work to meet the customer's needs. So the majority, the most popular setting, the most popular configuration or mode of operation that we call self-consumption. And in this mode, the inverter is given priority from the solar to charge the batteries, to support the loads, any excess to the grid, the loads that are on the main panel. Now, what happens when there's excess beyond that point? We also have a solution, but let's make the assumption at this point that the customer is allowed to export power out and perhaps gets some sort of credit from the utility company. So in this case, if I have solar, I will charge batteries, I will support the loads on the backup panel, main panel, and if I still have excess, then I would go out to the grid. To the meter, it gets counted as kilowatts out. This same self-consumption can go a little bit farther. So if the customer has priority because his electric bill is very high and he really doesn't want to be buying from the grid, I can go and program some discharge of the battery. So solar to the loads, when the solar is going down, it's not able to support the loads 100%. Now I'll start discharging the battery. Now, how much do you discharge a battery? That's 100% up to the customer. That's 100% of what the customer is trying to accomplish here. You can discharge them to zero. You can and are allowed through the configuration to discharge a battery to zero. Now, what happens if the customer has a power outage when you've discharged this battery to zero? They'll have no backup, right? So usually the typical system that does want to utilize the battery because the electrical bill is so high, they tend to go to discharge 30%, leaving 70% store reserve for power outage, right? So I wanted to highlight the auto transformer, but I already did mention that you do need this auto transformer for the systems. Now, same scenario, but now the customer is absolutely not allowed to export power out to the grid. Some places this is called zero cell, export limiting, we call it power limiting. When you go to the configuration in our app, you will find it under power limiting. The reason, because this inverter has a built-in meter, revenue grade meter with CTs. They come in the box, they come pre-wire, it's ready to go. All you need to do is enable the feature and install the CTs. Now, the placement of the CTs is critical, right? So if you look at my drawing here and you follow the smart meter, you see that the CTs are sitting right on top of all of the loads, meaning that I'm measuring everything. All of the loads in the house are being measured. And what happens now, if I enable the power limiting and I don't allow any export out, is that the CTs is measuring the direction of the current. And if I now have all of the loads are supported and I don't need any more and there's still excess, then the CTs will report the direction of the current, and the inverter immediately will react within seconds and stop any excess going out to the grid. So this feature is okay. I jumped. Yeah, here we go. All right. Next, just a little bit of visual reminder. I already mentioned it. What if the customer didn't want to have PV or can't have PV, or PV is coming later? So this inverter in this scenario is just simply working as backup only. It can charge the batteries from the grid and just simply wait until there's a power outage. And when there's a power outage, it will switch and support the loads with the batteries. And in this scenario, the batteries are always kept at 100% because since you have no solar, there's really no incentive to export power from the grid out to the power from the battery out to the grid, right? Because the only source of battery charging in this scenario is the grid. And again, just so you have a visual of what it would look like with no batteries. Like I said earlier, we call this internally battery ready. So this inverter will behave just like a string inverter. It's a PV inverter, and it can still do some smart things because of the meter. It can still do zero export, self-consumption. But in this scenario without batteries, when the grid goes out, then the inverter will turn off, right? And then when the customer is ready for the batteries, there's nothing changes here, nothing in the installation, everything is staying the same. The only thing is you bring the batteries, make the connections, and the inverter is ready to go. I already shared our fast transfer. This is when we have the backup loads where the inverter can transfer within 10 milliseconds. Most of the loads will not see it. Lights won't even blink, but that's enough to disconnect from the grid and keep the system off grid in a microgrid scenario until the utility comes back. Another thing, and I know I have people from all over the world because Krannich has customers everywhere. So if I have some people in the list here who are from California, you will see my slide and would understand what I mean by NEM3. The rest, don't worry about it. NEM3 is a very California specific utility program, but what is happening in a lot, not just in California, in a lot of places, is that the utilities have come up with a different rate tier levels during the day where the utility company is more expensive. This was a little bit more common in commercial applications, but it's now becoming a reality at residential levels. There's other states, not just California, where the consumer has different rates during the day based on the time. And then you can actually use the inverter, during one of our modes of operation, which is time of use, you can set up between this time and this time to utilize your batteries. So one of the more common times right now, especially because of the California, is 4 p.m. to 9 p.m. So we know that at 4 p.m., if we have sun, it's not at the same production level as at noontime. So at 4 p.m., you're having to supplement your self-consumption with the batteries. And ideally, what you're trying to do is you then start discharging the batteries at 4 p.m. and supplement with the batteries until 9 p.m. before you, at all times, you're still connected to the grid. You have not disconnected from the grid. You are still connected. You're just simply not buying from the utility company. You're utilizing your own power. Now, what is very unique about this specific system that I'm calling NEM3 on my slide is there are no backup loads. Now, this may be just very unique for California. I haven't seen it anywhere else in the US, but perhaps this is something that may be more popular in the future. So here, the customer simply says, I don't have any power outage. I don't care about power outages. They don't happen in my city or my neighborhood. But what I do care is I don't want to pay the high rates that I'm going to be charged between 4 and 9. So the only reason the batteries are here for this little drawing I have on the screen is to offset during 4 and 9. So during the day, the batteries are being charged with the solar, and they're only going to be discharging starting at 4 and just for the loads. Nothing goes outside, nothing goes to the meter because of the CTs are measuring and preventing any of our own power to go back out to the meter. Because at this point, we're really not getting any benefit for if the kilowatt is exported out to the meter for this scenario, it's okay. But it's zero benefit, very minimum. I'm exaggerating, very minimum benefit for the customer. So the customer wants to make sure that all of his power is utilized by his own house, right? So again, this is a very specific scenario, but I just wanted to share with everybody in the group here so you can see the flexibility that these inverters have within the logic of the inverter. Now a little bit about the ABP, which is the AC coupling version of this inverter. So quick look at the drawing and you see, well, I don't see any solar connected to the Goodwe inverter. That is true, because this inverter doesn't have MPPTs. You cannot connect solar directly to this inverter. So this inverter connects to the batteries, connects to the loads. So what's connected to the array? So now you look at the far right on my little drawing, you see just a general looking inverter that is managing the array. So a lot of the times an AC couple system happens because you have a customer who's wanting to add storage, but they already have a PV inverter. They already have solar and they already have a PV inverter. So the idea is I'm working this as a retrofit. I'm retrofitting the batteries because the PV is fine, the grid tie inverter is fine. And you know, within the industry, there's a lot of back and forth. Oh, more efficient, less efficient, this, that. The reality though, I think, is if the customer is happy with their PV inverter, it's really difficult to say to that customer, no, you got to take everything down and you got to replace everything, right? So the idea is here's a workable solution that we have been using since the late 90s. Probably the first time I heard about AC coupling was a very long time ago, and it was actually quite complicated. And I'm not going to go into details about that, but I'll share how we manage this. So I purposely show in a grid tie inverter that is not a Goodwe inverter. It could be any brand inverter. I'll say this, the best PV inverter for this application is what we call in the US smart inverters. And how do you know if an inverter is smart? Well, if it's fairly new, another way to tell is if it's certified for California Rule 21, pretty much anything that got the California Rule 21 forward, it's a smart inverter. And so now we know how that smart inverter is required to behave based on frequency changes on the grid. And we take advantage of that. So we know what the inverter is supposed to do, the ramp up and ramp down, it's in the code. So that inverter, so it doesn't have to be a Goodwe inverter, and I don't have to communicate. I don't have to have a communication cable and a communication protocol, nothing, because I know how this PV inverter is going to behave when the frequency is moving up or down. So that's what we're going to do. Now, normal operations, the grid is available. These two inverters operate like they're in different houses. They don't care. They're not really working together. They're both tied together in the single point of coupling, true, which is the grid, but they're behaving, the ABP is making sure their batteries are charged, and the PV inverter is doing its job, which is just simply pushing current. The moment we have a power outage, though, now things are going to change completely. Because on a power outage, what will happen is now we create a little bit of a microgrid inside the house, and the AVP is going to utilize frequency shifting, frequency what control, to control the PV inverter. If there's too much PV that's not needed, then the AVP inverter moves its frequency up, which then PV inverter sees the frequency moving up and starts throttling back the production. And then I need something big comes on in the house and I need to do more production, then the frequency moves back down. And all of this should be seamless. And it is seamless if we're working with a smart inverter. It's the most elegant solution for the AC coupling. Okay, so now let me touch a little bit about our batteries. Remember, both of these inverters will work with our Lynx batteries, as well as the other ones that I mentioned earlier. You can always reach out to us or Krannich. They'll be able to tell you what batteries are best suited for your application. So what you're looking at here is our largest tower, and this tower is 19.2 kWh. The top, you see they're like Legos. They're boxes on top of each other. The top box you see is the power management system. Then you have the feeds, which is the four legs. This is a floor standing model. Now every box in the middle comes individually in a separate, shipped separately to you, because this tower weighs near 500 pounds. So for weight management, each one of the battery modules is shipped to you in its individual box. That module weighs about 80 pounds, but it's a lot easier to manage and to move around than 500 pounds. It's a little over 500 pounds. So the idea is that you're stacking these. So the smallest battery possible for the Lynx is a 9.2 kWh, and that requires 3 of the battery modules plus the top ones, which is the battery management system. Right? If you wanted more battery capacity, then you can stack more. Maximum for the cabinet is 6. However, for this model inverter, you can do 2 towers side by side. So you literally could have almost 40 kWh if you wanted to. That's up to you. Another great thing, in my opinion, is that when you're stacking the modules one on top of the other, the way they're designed, it is not possible for you to cross the polarity of the module. They only go in one way. And you're not touching wires here at all. There's nothing inside the module itself that you're going to have to touch. There's no fuses, there's no wires, nothing at all. You just simply stack the module one on top of the other. And lastly, you put in the BMS. Once you power everything up, the BMS will auto-recognize the size of the battery. Okay, what's coming out of how you're connecting to the inverter from here? So if you look on the left side, and I have an arrow pointing to this box that says breakers. So right in here, you see that this North America model comes with a 50 amp breaker already built in, because this is a high voltage battery that ranges in voltage between 200 and a little under 500 volts. This is why the current is low, the voltage is higher and the current is lower. So on the right side, which I'm not showing, I think you see it on the other, yeah, you see it. I have the webinar dashboard covering the drawing, but you see the knockouts. On the other side, you will connect a positive and negative and ground, and you will also connect communication cables. So just a RJ45 connects to the battery and it goes to the inverter. That's it. Now, another unique thing about our battery here is that because it is not a single unit, not all inside, the inverter separate and the battery separate. Most of the pictures I am sharing during this presentation, you see that I show the inverter and then the battery is right underneath. That's fine, that's the most common application, but you may have a situation where I cannot fit the batteries right underneath the inverter. That's fine. You're only wiring this with a number 6. So you can put these batteries on the side. Now here in Colorado, because of the winter, all of our batteries end up inside, and that's fine. You can actually do an installation where the batteries are inside in a shelter of some kind, although these batteries are NEMA 4, they can go outside. The reason why they don't here in Colorado is the low temperature in the winter. For the rest of the country is no problem. And here I have some of the specs which I've already run with you. One thing sometimes get people a little confused. You see that plate, that hanger plate, and that's just simply so the whole cabinet doesn't tip over. This battery needs to be floor standing. So obviously if it's outside, you'd have to pour some concrete because of the weight. Like I said, it's over 500 pounds. The top cabinet with the six modules. Okay. During commissioning and after, how are we going to monitor and control all of the Goodwe inverters? So for all of the inverters that I'm sharing with you today, from the MSUS, which is the string inverter, AVP, hybrid storage, ABS is going to be monitored with the SolarGo app. SolarGo app is for the installer. SolarGo will help you through the commissioning, but it also can monitor while you are in front of the inverter. We also have an additional monitor, which I'll share in the next slide. So with this app, you will be able to commission all of the inverters in the UL catalog. So you have two options. So you have the near range Wi-Fi or Bluetooth. So when you're doing the commissioning, you don't have to worry about having to connect to the customer's internet. Provided that your phone has a signal, you can connect, and you can even do firmware updates from your phone. You don't have to connect to the customer's internet, because sometimes the issue with connecting to the customer internet is because you need their password, and you may be going through the commissioning process, and if you don't see the customer and you can't get connected, you can still finish the commissioning. For the most part, the commission is very simple. I have a video. We clocked ourselves commissioning in MSUS, and it took 2 minutes. Some of the tricks why we can go through the commissioning very fast is because we don't require you to do a firmware update during the commissioning. Every single one of our inverters come from the factory ready to go. So if you have a customer that doesn't have internet, it's never going to get a firmware update. That's fine. The inverter is going to work without problems. Now, if you have internet, we will handle the firmware updates from our side. There'll be a push. If we need to do a firmware update, it will be a push. You don't have to stay on site. I was actually recently talking to a customer, had just finished up an update, and he'd called our tech support team, and we did the update for him, and he was already in the car and going home because he was done for the day. He didn't have to wait in the site for the firmware update. Most of the time, it's a brand new inverter, recently launched. Yes, there's going to be firmware updates, and the first thing the inverter is going to want to do, but it can do it on its own automatically. You don't need to monitor that part. So you finish the commissioning. Last step of the commissioning is connecting the inverter to the internet, and at that point, the inverter is going to automatically do the firmware update. And here is the different modes of operations that we have talked about, and you can do these for our storage inverters. You can do them on site directly in front of the inverter, or remotely using our Sims app, which I'll talk about it here in the next slide. So with the Solar Go, you can only do the commissioning while you're in front of the inverter. If you're not in front of the inverter and the inverter is connected to the internet, you can still do configurations using Sims. And like I said as well, you can always contact us, and we can actually, if the inverter is connected to the internet, we can actually help you with some of that configuration of anything that is not working correctly. And now we're going to talk about our new CNI inverters. Actually, this one is not new. We've had this one already. This is the 50 and 60 kW 480 volts. This is our SMT series of inverters. Just like all our other inverters, it already comes with the arc-full rapid shutdown and power meters all included. This inverter is 1,000 volts. So all of the other ones that I was mentioning earlier are residential, so they're all 600 volts. That's just the way things are per code here in the US. So for a rooftop, this would be something that be common in a commercial building, office building, like a Costco, like a Walmart, something like that. This inverter does have the rapid shutdown transmitter, but it is also already compatible with UL 3741. So if you are doing any of the CNI projects and you don't want to use rapid shutdown, this inverter is already in partnership with a number of the racking companies available in the US, is already UL 3741. And this is our new one. This one is just being launched now. And this is the same inverter, but at 208. The other one is 480, and one is 208. And it comes at a 22 kW or a 28 kW. It has 3 or 4 MPPTs, the same features built in, rapid shutdown, arc fault, built-in switches on the AC side and the DC side, and capable of complying with lockout, tagout on the DC side. Also 1,000 volts, and also has all the certifications required in the US for this type of inverters. So I'm picking the SMT to talk a little bit about the meter, but it's the same feature that I shared earlier with the residentials. The same idea that these meters do for our customers. Some of the inverters, this meter is included. It comes inside. For the SMT, it does not. It's an option. But the features, because of the meter, is the same. So at the very basic, you can just monitor loads. So we have the monitoring platform where the customer is going to be looking at their PV production. In a residential scenario, it's their home. In a commercial scenario, it's the building. And you see the PV production, and then with the meter, now you see what are the loads consuming and where's the power coming from. And now you can have more granularity of what's coming from the utility and what's being utilized by the solar. Just like the residential inverters, it can also do power limiting or zero cell that I was explaining before. So if you had a situation with a CNI project where you couldn't. Now, one thing I forgot to mention, and this is actually more important on the residential side, but I'm not going to skip on the slides. I'll leave it here because it's still relevant. But it is not uncommon to come to a residential customer in finding a very small service panel, typical 100 amp or something like that. And when you look at it, you say, well, you know, we should probably do an upgrade. This is too small. And for whatever reason, it is not possible to do an upgrade. Because of this meter, you can actually derate the breaker. You can derate the inverter so it doesn't trip the breaker, so that you don't have to do. So this is part of our PCS or power control system, which is a certification part of UL 1741 PCS, which is mandatory in California. But for the rest of the country, is very relevant because it isn't unusual to run into the scenario where you cannot upgrade and you cannot put a big 60 amp breaker or 40 amp breaker. You can derate the breaker because you can derate the inverter. And that is true with the residential inverters that I was showing earlier, as well as this CNI inverter. Let me talk about a little bit about the transmitters for the rapid shutdown. I'm showing a wiring box here, but all of our inverters come with these two choices. And all you have to do is specify when you call Krannich and you say, I want this model from Goodwe, you tell them which transmitter you're interested in, Tigo or APS. And they'll be able to ship you the box ready with this wired and ready to go. Soon, we'll have a third option this year, which will be these two plus our own Goodwe transmitter. And that will be entirely up to you which one you select. Something that recently came up, talking to an installer, that was actually doing a repowering of an older system. That inverter failed. It doesn't exist anymore. It's not available in the market. And he was bringing the Goodwe inverter to replace the old inverter. But the old inverter didn't have rapid shutdown. In this area where he was calling me from, it wasn't necessary. The system was grandfathered in. You didn't need to do rapid shutdown. So his question was, what do I do with the rapid shutdown? No problem. You just simply disconnect the power cable. So there's 12-volt cables inside, and you just disconnect them and you disable it. It's done, no problem. It also brings me to another question that I've had from installers. What if I don't want the CTs of the meter? Or what if the CTs are too short for where the loads are, right? So the CTs and the transmitter for the rapid shutdown, if you don't need them, you don't have to use them. Obviously, this is code, so you need to understand it in your area for rapid shutdown if it's allowed, and if it is, you don't have to use it. Same thing with the CTs. Or you want to use the CTs in the meter for monitoring the loads or export power, but the CT cables are too short. And for that, we have a couple of solutions. And all you have to do is call us to our support line, and they will give you what, and then you can decide which is the easiest way for you to extend, so you can get to where the loads are. So one of the things that we are seeing in the U.S. now, we're seeing this outside the U.S. Much sooner, but this year we're starting to see larger and larger modules, right? So we see in the market today already 530, 550 watt modules in larger. And although I am still talking about CNI product, the SMT, this is where we are seeing these modules much faster. I'm starting to see these big modules in residential already. So it's become quite important that the MPPT maximum current can handle these modules, because as the modules are getting bigger and bigger, the voltage gets higher and the current gets higher. So the SMT inverter has a 15 amp. It's actually 30 amps per string, but you can put 2 strings per MPPT. So it's 30 amps per MPPT, and you can put 2 strings per MPPT. So that means you can put 15 amps per string, which it can accommodate, at this point, can accommodate most of the solar modules out in the market. But this is something that you do have to keep in mind, because what has happened traditionally with solar modules is that we get what we get. What's starting to ship, and then all the distributors will have, I mean, I remember 165 watt modules, right? They don't exist anymore, or at least I haven't seen them in a long time. So as the modules are getting bigger, distributors are getting the bigger modules, then you won't be able to get the other modules. So you have to be sure. We do have a string sizing tool on our website called Easy Designer 2. If you go to our website, the global website or the US website, you'll find it in both places under support, and it will say string sizing, and you can model the array. You can pick the inverter, you can pick the modules. If the module you don't find the module, you can manually enter the one that you have, and then you can do string calculations that way. For the SMT, we have a wide range of environments, from humid to high heat. Obviously, it has protection for lightning, indirect hit, of course. And then lastly, is I wanted to share with you our cloud portal, which is our SIMS portal. And it comes in two flavors. It's a phone app or a desktop browser app. Now, for you as the installer, the benefit of the desktop is that you can have all of your installations at a single glance in a dashboard. For this, you have to get a organization code. You get that from us. We offer installer trainings. We have a program that we call Quick Start Training Program, which is targeted for the commissioning of all of our products. So you're ready to commission, you got that inverter on the wall, all wired up, and you just want tips on how do you commission this inverter, you get in contact with us, and we have the Quick Start training. Part of the Quick Start training, once you finish that, and it's 20 minutes, 30 minutes. It's a fast training. You also then can get the organization code, and that way when you log into the portal, you see all of the sites that you have installed. Now, for the homeowner though, the homeowner only wants to see their own. So they register directly. They don't need to contact us or anything like that. They just go to the portal, they log in with their credentials, they'll put the inverter serial number, and they will be able to monitor their system. Like everything else, all the graphs, historical data, if there's any alarms, if there's any problems. Additionally though, this SIMS has an app, and the app actually has more features than the desktop, and especially more features for the storage product, because the app will allow you to do configurations based on, for the storage product, it will actually let you do remote configuration. So you don't have to be in front of the system. So quickly here, I got some of the graphs. I know they're small, but you can actually go to our website right now if you like. Go to SIMS. There's a demo. So before you log in or register or anything like that, there's a button you can press demo. And actually what I like to do, I have the app on my phone, and when I'm talking to a customer, an owner that is interested, I pull up the phone and I open the demo and I show them. It's not a real site. The demos are not real sites, but it gives them the idea of what this is what the monitoring will look like. This is where you're gonna be getting from this inverter. And here are how you contact us. And while you guys look at this, I'm gonna see if I can grab at least one or two questions that I can answer. And if I don't get to your questions, I will reach back to you via email. The size of the transformer, the ATX. So the ATX is one size. We only have one size that fits all of our inverters. So it's big enough for our largest 9.6 kW inverter. So it's only one size for that inverter. And then another question from the same person. Perhaps what I'll do with this question is reach me via email, and I'll be happy to send you more information about the transformer, and then we can chat a little bit more about that. And I don't see any more questions, guys, but if you think about anything else, here's my contact information. Reach me directly if you like. You can always get information directly from Krannich. And thank you for taking the time, and hope you have a wonderful day.